this chapter?
Angle relations.
A lot to this section. It's not that bad, but there's a couple of things, really a lot of things that you'll use over. It's a very important section. A lot of things you use over and over and over and over again. But first, we're just going to start by basically, we are going to define a lot of terms, and then we'll go into more detail about a couple of these terms after we're done and do an example or two. Now, first things first. What's the first one in there? A linear, or no, adjacent. As I've told you a lot of times, I'll use that word, sign for angles. Adjacent angles. To me, the word adjacent means beside. Okay, if you have two things beside each other, you know, adjacent. You can't really use that as your definition because there's a little more to it than that. But at the same time, adjacent angles share a common side and vertex. I guess I should say two angles that share a common side and vertex. I'll draw three examples up here. Only one of them are adjacent angles. Which one do you think is adjacent? Left, right, and middle?
Left.
You are correct. Those two are, that one is adjacent. Does anyone know why the middle one, why this one's not adjacent?
Because it doesn't share the same vertex.
They share a side, but they don't share a what?
Vertex.
They're kind of beside each other. And I guess that's, I'm trying to, basically, you can think of it as two angles that are beside each other, but there are some situations where that doesn't work. Now, what about here? They're kind of not beside each other here. They share a vertex, but do they share a side?
No.
No, these are not. And of course, in the really real world, you might kind of say that those two angles are beside each other. You know, they're two angles sitting beside each other, but they're not adjacent. Why?
They don't have a
They don't have a common vertex.
or a common side.
Or a common side. But they, I guess that one could probably be the one that could debunk the beside more than any. But at the same time, in geometry, those are two things beside each other, share a common vertex and side. Okay? So we understand what adjacent is. Okay, easy peasy. Now, second thing. Very important, linear pair. I like to say together the angles create two opposite rays. Or what you'll hear me say more than anything is a straight line. It's kind of an oxymoron there because all lines are straight, but you could draw a straight line, couldn't you? Would be a line in geometry, but okay. Together, what are opposite rays? We talked about that yesterday, right? They go directly opposite and create a line, right?
Yes.
So, Which one of these is a linear pair, which one of these isn't? Assume that my lines are straight when they look like they're
The
straight.
second.
Right.
The one on the right is a linear pair. Why?
Because it has a.
Together they create a straight line, don't they? Think of it like this. I have these two angles here. Everybody look up here. And I scooted them together. When I combined them, crooked line, right? That wasn't perfectly straight, right? So these two aren't a linear pair. However, when I scooted these two together, what happened? Created a what? That's why they're a linear pair. So these are a linear pair. These are not a linear pair. Third thing we're going to talk about. Vertical angles. Very important as well. Something to use over and over again. Give you a second to finish writing the other. Vertical angles. These are created when two lines intersect. The pairs of opposite angles are called vertical angles. So I have two lines that intersect. How many angles are created when two lines intersect? Four. I'll number them. 1, 2, 3, 4. Everybody look up here, you can finish writing in just a second. Okay. Which ones do you, if the opposite angles are vertical angles, which two do you think are, give me two pairs, sets of vertical angles there.
1, 3.
Angle 1 and angle what?
3.
And what are the other two?
2 and 4.
Angle 2 and angle 4. It's hard to read, but hopefully you are listening so you know I'm saying vertical angles there. So pretty easy to tell which ones are vertical angles. Anytime two lines intersect, the opposite angles are vertical angles. So you always create two sets with the phone. Doesn't need to be out there in notes. Unless you're taking pictures, so you can see it. Like I said before, that's not a bad idea to Zoom, because if some of you have some of the newer smartphones, some of you don't, that's fine, but you might find it's easier to zoom in, take a picture, and then write from that. It's not everybody can have the see the front of the class, right? Okay, so everybody got this written down? Can I erase it? Okay, what we've dealt with here are basically things that kind of, each one of these needed a picture, did it not? You know what I mean? We had to have, you know, kind of see adjacent, linear, and vertical angles. The next things we're going to deal with are they're going to be relationships dealing with the angles measured. How two angles relate to each other according to their measure. These kind of dealt with their location or how they combine. Okay, and these are ones you've probably heard of. First one is complementary angles. Second one, supplementary angles. And the third one isn't actually angles, but it's the angles created that are important. Perpendicular lines. Okay, those are leave space, of course, to write which ones if you're writing right now. Each of these deal, their relationships to each other are dependent on their measures, not their location, not whether they're beside the other one or this or that. Now, or in a lot of cases, are we going to deal with complementary angles that might be adjacent? Sure. But complementary angles don't have to be adjacent. The only thing that makes something a complementary angle is when two angles measure add to 90 degrees. They are complementary angles when they add to 90 degrees. Doesn't matter if one's sitting over here or one's sitting over there. So basically the measure of angle A plus the measure of angle B, if they're complementary, what does it have to equal?
90 degrees.
Exactly right. What do you think the complement of a 30-degree angle is?
60.
You just learned what complementary meant. The complement of a 30-degree angle is a 60-degree angle. Why?
It equals 90.
Because they add to 90 degrees. The complement of a 50-degree angle, 40-degree angle, right? Okay. Supplementary angles. Very similar. That's when two angles measures add to 180 degrees. So when two angles are supplementary, the measure of angle A plus the measure of angle B, for them to be supplementary, what does it have to add to? You notice how I'm kind of making an equation here? Remember the thing we did, for example, for number 1-4? Creating an equation, you think we might have to do that here? Yeah. Then you're going to have a problem where they say the measure of angle A is 2x plus something, and the other, and we're going to have to say this plus this equals 180. I bet so. And this is something you've probably been introduced in some aspect a little bit before. In fact, I think even I want to say, remember, Gabe, my fourth grader, they used the word complementary, supplementary for some reason, talking just basic geometry stuff, and I think he had complementary, supplementary angles, those are all work. Basically just learning that when they add together, they went to 90. It wasn't anything complicated, but I was a little surprised. Perpendicular lines.
I have a question real quick.
Yeah.
Are linear pairs the same as supplementary angles?
We'll get to that in just a second. We're going to talk a lot more about linear pairs and vertical angles in just a second. All right, that's a good question. That's kind of, I'll get on my soapbox on that. Perpendicular lines, when two lines intersect to form four right angles, said to be perpendicular. And beside it, I'm gonna make a little sign. What do you think that sign means? Yeah, not the parentheses, but the upside down T.
Right.
Yeah. Perpendicular, that's the sign for perpendicular. So a lot of times you'll see the rest of the year, we're just gonna say perpendicular, instead of writing the word, I'll put that sign. You know, if I had, you'll see it like this. If this was line L and this was line M, okay? You'll see this. L, and then they'll have that sign, M. What do you think that's saying?
L is perpendicular.
Is perpendicular to M. Now, and here's what you'll see. Everybody look up here. You can finish writing in just a second. Eyes up here. You guys know what this means? You should have seen that sign. You guys seen that before, haven't you? Yeah, when they put a little box right there, and usually being red in the book, that means that it's a 90-degree angle. So basically, when these two intersect or perpendicular, all of these angles are going to be what? 90 degrees, right? All right, so let's get all that written down. And then we're going to talk a little more about linear pairs and vertical angles. And we'll get started on our assignment. Get it? I know. You could read ahead and see what I'm going to talk about, linear pair and vertical angles, too, right?
Yeah, that's probably what I did.
Yeah.
I was thinking about that.
Does anybody else need to stuff here? Everybody got it written down? Okay. All right. Linear pairs. And I want all of you to watch up here, not write. But what I'll have you write down after this won't be much. I'm kind of making points with drawing, okay? So don't write any of this down until I tell you. Okay, tell me how many degrees I went. Go right here.
360.
I went 360 in degrees, right? Everyone agree? How many did I go?
180.
All of you, none of you have a problem with that at all, do you? That's pretty easy, isn't it? Semicircle, circle. Okay. What's the measure of that angle?
180.
Good. If you think about it, it's a straight line, so it went from here to here, and it was what? Okay? That is very important. Anytime, and granted I didn't draw a very good line, but if you think about it, what is a linear pair? Together the angles make a what?
180.
A straight line, correct? Would you agree? Since it's a straight line, what's that got to be?
180.
So anytime you have a linear pair, what do you think you can say about those two linear pairs? Measure of angle 1 plus what?
That's something.
Will equal what? Or they are supplementary. Okay? That's very important. Now, you may think, well, why are you making a big deal about this? That's obvious. Yes, it is, but you'd be amazed at how much this is messed up and how much people don't think about it. You will use this fact again and again and again. Stop writing. Throughout the whole year. What do I mean by that? You also hear me say this over and over again. What's the measure of that angle?
90.
Are you sure?
No. Well, it could be.
Pretty close, isn't it? Could you discern if it was 89.8 degrees? Could you tell the difference between 90 and 89.8? No. So well, you know what the book will do? Unless they tell you to assume 90-degree angles are 90, what will they do to tell you that's a 90-degree angle probably?
Put a square.
Put this on. So you can't go by what it looks necessarily, can you? You go by that sign right there. Now you know it's 90 degrees. If I just draw this, you cannot assume that's a 90-degree angle. Unless you're what? Told. However, one of the nice things that you can assume, what's the measure of that angle? That you can. That you don't need to be told. Another thing, I'll try to do my best here. You know, there'll be a lot of problems where you look at it. What do you think I tried to draw there? Two what? Acute. Okay, yeah. But what do they look like they are? Almost. Pretty close to being congruent, right? I can't assume they're congruent unless I do what? Make those marks like that, right? The book gives you that mark, you say, oh, okay, those two are congruent. They're the same measure. But you can't assume it if it just what? Looks like it. The great thing about linear pairs, it is one of the few things that you can look at the problem and you can assume. In other words, straight line. Guess what that angle and that angle has to be? Period. I don't have to tell you that. The book won't tell you that except for after this point. You see, this is why I said these two are linear pairs, but from that point on, anytime you have a straight line, what about those two? What do you think those two angles add to?
180.
Anytime I make a linear pair, I don't care how crooked I make it. What about this angle and this angle? What are they going to add to? Period. I don't care how many I make in there. What do you think these three angles are going to add to? What do you think these angles are going to add to?
Sorry, I was wondering if is there any such thing as like a 20-degree angle, or would it just be a 20-degree?
We're not going to deal with those much.
But so it could go past 180.
You won't. In geometry, you won't deal with them. Now, look at here. So each time, we're going to have 180 degrees. So anytime you see a straight line and an angle in between, what do you know about those two?
They are supplementary.
Right now, I can write that equation. Okay? You will get over and over and over and over and over again. You will be dealing with much more complicated, not that much more, but much more complicated theorems and postulates and situations. And then they'll throw in there something like this that is your last thing you need to get the answer. That's a straight line. So don't forget that. We use it over and over and over again. That is one of the few things you can go by what it looks like. Okay? Everybody got that? Understand that? Yeah. So anytime you see a straight line, you know it's a 180-degree angle, right? And then, okay. Now, the other thing we're going to do, so write this down. Write the picture I had here. So it's in your notes. The linear pairs, measure of angle 1 plus the measure of angle 2 will equal 180. Do write that into your notes. Here, real quick. I almost forgot that I told you not to write. If you want to, you can draw a little circle saying that that's what. I'm telling you guys, you use this so much. The other thing that you can go by how it looks are vertical angles. And another reason why I'm spending extra time on it. They are always I saying all different sets of vertical angles are congruent? No, when you have a pair of vertical angles, you know, they're opposite angles, they are always, always, always congruent. So when two lines intersect, there are 4 angles created here, are there not? Guys, don't write, listen. I'll let you write it down in just a second. Stop. So we can get through it. Guess what? Angle 1 will always be congruent to what?
Angle two.
No.
I mean, angle three.
Angle 4 will always be congruent to what? Period. End of story. Remember when now if you draw a tube, this is the one thing you can go by and say, oh, they look like they're congruent. Oh, wait a second, they are. Because of this theorem, because of saying that vertical angles are always congruent. If they're exactly opposite, think about it. How many different ways can I draw angles, 2 lines intersecting? A lot of different ways, can I? One thing I know for sure, that's always true. I don't care how much I do it like that, what do you think? Opposite angles are what? No matter how I do it, if you see 2 lines intersecting, the opposite angles created are congruent. Now, are there exceptions? No, there's not exceptions to this, but there are ways they'll try to trick you. Are these opposite vertical angles?
No.
They aren't, are they?
No.
Because this line, the vertical angles created is that this line what? Kept going, right? You see what I mean? So they can trick you like that. But these are vertical angles, and guess what? If they drew it correctly, they're right? Kind of see what the difference I'm saying there? Okay? So this is another thing you can go by. How it looks, correct? So anytime 2 lines intersect, the opposite angles are what?
Congruent.
Congruent. Now, before we do anything, I mean, do you think you're going to have a problem like this? Or let's go x plus 4. Think you have a problem sitting just like that?
So I'm thinking graph actually the same.
I bet you'll have a problem like that. Now, this looks like an algebra problem, does it not? Now, of course, they'll probably do this and put degrees around it. This represents the measure of this angle, this represents the measure of that angle, correct? What do I know? Now, the picture, they tell you nothing but that. What did I tell you? You can't go by how things look on vertical angles. What do I have there? 2 lines intersecting. No matter what, no matter how I make them intersect, what do I know? That one's congruent to that one. That one's congruent to what? Which means their measures are equal. So what do you think would be my equation here?
X plus 4 equals 2x minus 2.
How am I going to solve this?
Minus 4.
Minus 4. And then what am I going to do? I'll get x is equal to 2x minus 6. Subtract, I know, subtract 2x, subtract 2x. Don't make a mistake here. Negative x is equal to negative 6. What do I have to do now? Negative 1, x is equal to what?
6.
So you think you're going to get probably a problem like that? But then, hey, wait a second. Don't you think I'll do something like this then for the second problem? They're going to make you think. Think they're going to do something like that? Now, here's my question.
180.
Here's my question. Are they, what is congruent here? The opposite angles are congruent. So this angle is congruent to what? That angle is congruent to what? So does vertical angles help you here at all? No, it doesn't. When that doesn't happen, what was the thing I talked about before? Linear what?
There's
Well, I made this a little different. Would this look a little more familiar if I erased the bottom of that? What does this make?
180.
Straight line, 180. You need to be able to kind of see that, and with that still written down. Does that make sense? See that straight line, with that still being the case. So what do I know about here to here? So how can I relate those two things there? 2x plus 10 plus what? Is equal to? Have I created a valid equation? 3x plus 40 is equal to what? What am I going to do now? 3x is equal to what? Divided by 3. Stop putting your stuff up. 3 to put that 4 times.
4.6 repeating.
And 2/3. Stop putting your stuff up. Right here in zippers. Is it
I think it's 46.
46 and 2/3?
I think.
Now, guys, I'm telling you all the time. You guys might take pictures of that. We're just about to do that because I guess we're getting towards the end of the hour. But I'm amazing. I'll see people that will do this every time. They get an algebra problem. Guess what they do? They say, "Oh yeah, they must have had the 180." Or they'll make the mistake and say, "Oh, algebra looking problem. They must be what? Equal." But every time, are the situations going to be the same? And remember, you also can look at this. I actually uploaded it. I'm recording right now, so you have this to look at. Okay.
But how can you record if you're marking on the board?
I turned the camera towards here.
Whoa.
That's why my desk is right there. Because my desk used to be over there, and I couldn't do it. I couldn't ever write on the board and record it.
Now you're on the lecture.
Hey.
Remember I told you not to lean too much? Okay. What's the assignment in the book?
1 through 5.
1 through 5 odds.
1 through 5.